In part 1 of this lesson, we looked at finding the slope of a line given 2 points, and so we had our formula for that, which was the slope is equal to the change in the y's over the change in the x's. And I think probably in that earlier one I did y sub 2 minus y sub 1. The subscripts do not matter, whether you have a 1 here and a 2 here or the other way, y sub 2 minus y sub 1. All that the subscripts are to show that we're talking about y's from different ordered pairs. What does matter is that this y and this x come from the same ordered pair. And so we had our slope formula. We had what was called our point slope form, which was y minus the given y is equal to the slope times x minus the given x. And we could use that if we were given a point and a slope. We looked at our slope-intercept form, which was y equals mx plus b, where b was the y-intercept. And then we looked at graphing using our slope and y-intercept form, and that's the easiest way to graph when you can, is the y equals mx plus b. The slope tells you how to get from one point to the other. The b is your beginning point. You can think of b as for the beginning. So that's where you begin on your y-axis, and then your slope tells you how to get to the next point. It's your directions. And we talked about it being rise over run, or vertical change over horizontal change. There is another form that we sometimes write our equations in, and that's in what we call the general form. And that's ax plus by plus c equals 0. Now, depending upon which book you're using, some books will use this as the general form. Some books will use ax plus by equals c as the general form. All that we did was we subtracted c, moved it to the other side, and since we don't know whether c is positive or negative, it's just equals c. So these are both different forms of the general form. In the rest of this lesson, I'm going to use this first form for the general form, but you may also see it in the other form. And what we want to do is to look at how to take it from the general form and put it back in slope-intercept form so that we can graph it. And then we're also going to look at how to find the x-intercept and the y-intercept from the general form and graph using those 2 points. So let's take as our equation 3x plus 6y minus 12 equals 0. Now, if we wanted to graph this, then it would be nice to know the slope and the y-intercept. And so to do that, what we're going to do is we're going to solve it for y. So we can subtract 3x, and we can add 12 to both sides. And so if we do, then what we have left is 6y is equal to negative 3x plus 12. And we usually write our x term first so that it will be in slope-intercept form. And then divide both sides by 6. Now when I divide by 6 over here, I'm going to go ahead and distribute that 6. We've written it both ways. It's the whole thing divided by 6, which means we have to distribute our division. So we get y is equal to 3/6 reduces to 1/2. So negative 1/2 x, 12/6 reduces to 2. So in this case, we have a slope of negative 1/2. So we know our graph is going to be going down as we go to the right. We have a y-intercept of 2. So if we wanted to graph that, we're going to graph y equals negative 1/2 x plus 2. Then our starting point is at 2. Our slope is negative, so that means we're going to be going down 1 unit to the right 2, down 1 to the right 2, down 1 to the right 2, as many as those that you want to do. and then we will draw our line through there. And our line does go infinitely in both directions. And so we have our line through those points. Let's take another one if we can go through and find those points for. Let's say that we have 6x minus 5y minus 20 equals 0. Now, we can go through and we can subtract 6x and subtract 20 and have everything move to the other side. Add 20. And so we would end up with negative 5y is equal to negative 6x plus 20. Then we're going to divide both sides by a negative 5. And we get y, a negative divided by a negative is a positive, 6/5 x, and a positive divided by a negative is a negative 4. Now, one thing that you could have done, since we just want to solve it for y, it's okay whichever side. So we could have taken our 6x minus 5y minus 20 and added 5y to both sides. And had our 6x minus 20 equals 5y, then dividing everything by 5, you can see we're going to get the same answer, 6/5 x minus 4. And if you don't then like the y being on that, you can use what's called the symmetric property and just switch it around. If that equals y, then y equals 6/5 x minus 4. So that would probably be an easier way that you could do it in one step, is to move the y to the other side and solve. So our y-intercept is negative 4 and our slope is 6/5. Well, our y-intercept was negative 4 and our slope was positive 6/5, which means we're going to go up 6 units to the right 5. Up 6 and to the right 5. And then we can draw our line through those points. Got off just a tiny bit. But we have our line then through the points. And the line represents all the points that will make that equation true. So if you're given an equation in the general form and you need to graph it, then one way is to put it in slope-intercept form and graph your points using your slope and your y-intercept. Another thing that you can do is to use what we call the x-intercept and the y-intercept. And so if we took an equation in the general form, okay, then we can go through and we can graph it using a little different way. Let's take the equation 4x minus 3y minus 6 equals 0. Now there are certain areas where your equation is often bounded by the x and the y-axis. You're only going to be talking about things in the first quadrant. And when you are, then you don't need all those points in the other quadrants. So it's often nice to graph your line just using your x and your y-intercept. Well, if you think about your two intercepts, your x-intercept is where you cross the x-axis. The thing that we know about a point where it crosses the x-axis is that the y value is always 0. The thing we know about the y-intercept where it crosses the y-axis is that x is always 0. So if you have an equation and you want to know where the x-intercept and the y-intercept is, then that's the easiest way. To know where the x-intercept is, we're going to take our equation and wherever there's a y, we're going to substitute in 0. We're wanting to know what x is when y is 0. And so we have 4x minus 6 equals 0 because 3 times 0 is 0. Then solving for x, we would add 6 and divide by 4. Now 6/4 will reduce to 3/2. Now again, we don't write an intercept as x equals, so you would have to go back and say the x-intercept is 3/2, or you could just write it as an ordered pair, 3/2, 0. So we have our x-intercept. To find our y-intercept, we substitute in 0 for x. So we'd have 4 times 0 minus 3y minus 6 equals 0. So negative 3y minus 6 equals 0. Adding 6 and dividing by negative 3, we get y is negative 2. So our y-intercept is negative 2, or we can write it as an ordered pair, 0, negative 2. You don't have to write it both ways. I'm just writing it both ways so that you know the two acceptable ways. You don't want to leave it y equals negative 2. Okay, if we went to graph this, then we would plot those 2 points. On the x-axis, we said 3/2, which is 1.5. It's halfway between 1 and 2. And then our y-intercept was negative 2. So we have those 2 points, and then we want to draw the line that goes between those. Not that line, but this line. And so that would be the line that would represent that equation. So we can graph using not only the x-intercepts, or the slope and y-intercept, but also by using our x and our y-intercept. So let's do another one that way and graph it using our x and our y-intercept. And that's often a very nice way of graphing. And as I said, especially if you needed to bound what you're talking about by the x and the y axis. So we've got 3x plus 5y plus 15 equals 0. And what I like to do is I like to go ahead and write down my ordered pairs. For the x-intercept, I know that y is 0. For the y-intercept, I know that x is 0. Okay, so when I'm substituting in 0 for y, then I know that what I'm getting is my x. And basically that term is going to be 0. So we end up with 3x plus 15 equals 0. Subtracting 15, 3x equals negative 15. Dividing by 3, x is negative 5. So our x-intercept is negative 5, 0. Then we'll substitute in 0 for x. Well, that basically makes that term 0. So what we're left with is 5y plus 15 equals 0. Subtracting 15 and dividing by 5. So y is equal to negative 3. Then to graph this, our x-intercept was at negative 5. Our y-intercept was at negative 3. And we draw the line connecting those points. And we go through those points. It does go on forever. It's a line that represents all of those. So that gives us another way of graphing our equations. So we've looked at our slope formula, at our point slope form, y minus the given y is equal to the slope times x minus the given x. Our slope intercept form, y equals mx plus b, and at our general form, ax plus by equals plus c equals 0. And then just as a reminder, we also have our vertical line and our horizontal line and the things that happened there. So if you think about it with our vertical line, if you remember, our slope was 0, our vertical line, our slope was undefined. And what I always like to think of is if my line is vertical, then it only crosses, let's just think about it, it only crosses the x-axis. So a vertical line is always in the form of x equals a constant. The slope is undefined. A horizontal line, okay, it only crosses the y-axis. And so it's in the form of y equals a constant, and the slope of a horizontal line is 0. These are the main things then that we'll talk about when we talk about our linear functions and the slope.